chance of being wrong, well, then I can put all 5% at the top end. I don't have to worry about the bottom end, right? Well, in that case, the z-score that I need to exceed to make this unlikely enough to only occur 5% at a time if there's no difference between the regular season and the playoff season is still 5%, but the z-score only has to be, I believe, 1.64. We can look it up on our z-table to give us an area that would be 95% here and 5% there. So a one-sided test is in a lot of ways less rigorous, easier to prove, less rigorous, right? So that's what we would be looking to exceed if we were doing a one-sided test. And we're only looking at that side. If we're doing a two-sided test, it's a little tougher. We got to go to 1.96. So that value, if it's a one-sided test, is our critical value of z. If it was a two-sided test, our critical value of z was going to be equal to 1.96. You guys get that? Does that make sense? Right, exactly right. Joshua's got it exactly right. Good, good. Okay, I hope that helps a little bit because I know there's a lot of confusion about the ideas of these one-sided tests versus two-sided tests. Okay, so let's go back to our example and see what we got. Okay, we go back to our example. Okay, we got these various values. We're going to say that x bar minus mu over standard error is equal to, what is it equal to? It's equal to 41.95, minus 40 over the standard error. Well, standard error in this case is it's going to be standard deviation divided by the square root of n. It's a one-sided test, so we don't have to deal with it's a single sample test, so we're only dealing with one standard deviation. When we move on to a couple of problems from now, we're going to be dealing with more than one standard deviation, and things can get a little sticky. Okay, so okay, divided by it's going to be the standard deviation 5.8, right? Divided by the square root of the sample size. I'm just going to go ahead and put that in. That's going to be 8, the square root of the sample size. So now I'm going to take advantage of Excel being in the background here, and I'm going to say 41.98, okay, and 40.95. That's actually. And our 5.8 and our standard deviation 8. And let's see what we got. This is going to be equal to this minus this, put them in parentheses, divided by 5.8 over 8. I'll put that in parentheses too just to make sure. I think it would work correctly because they're all the same order. But okay, so I get a z-score of 2.68. Okay, now we mentioned that the z value that we have to exceed for a two-sided test is only 1.96. We've exceeded our z-score that we need, our critical z-score, 2.68. Oops, didn't mean to do that. We've exceeded our z-score. Our z-score is 2.68. We've exceeded our critical z-score. What do we do? What's our conclusion now? No, it's the square. The sample size is 64, Kara. So I used I did it in my head, right? That was going to be a standard error is equal to 5.8 divided by actually the square root of the sample size, which was 64. I should have made that. I really shouldn't have taken that shortcut. Okay, so so what do I do now? What's my conclusion at this stage? My z-score that I calculated for the distance between these two means is they're 2.68 standard deviations apart. My critical z-score, what I needed was 1.96. So my conclusions, less than 5% chance that we're wrong if we reject the null hypothesis. Okay, everybody in agreement on that. In this case, we reject the null hypothesis and accept the alternative hypothesis. They are giving out more fouls during they are giving out a different number of fouls than during the regular season. And we kind of can just look at the differences and say, well, it seems like they're giving out more rather than less. But that's not really what we were asked to determine. Okay, so I need a few more yeses that you guys get this. Um, is this understandable, or is there still issues with this? Okay, good, good. I like getting yeses. Good. All right, let's take a look at this from the perspective of a proportion now. Okay, sometimes you're going to get a data as numerical data, like we just got there. Sometimes going to be proportions. Now, again, this is a single sample t-test. Does the home team win more often during the playoffs than during the regular season game? And again, we have a sample, right? During the regular season, the 68% of the 58% of the time, the home team wins. During the playoffs, during 64 games, we found that 65% of the time that the home team wins. Okay, so we took that same games that we did before again, randomly sampled, random samples, independent, not a particular team or league, and so on and so forth, and presumably the distribution of the percentage of times that if we took the samples 64 over and over again, they would be normally distributed. The results that we would get around whatever the true population, the true mean for home team wins is. Okay, so this is for the regular season. This is for the playoffs. Okay, so now let's take a look at how we would do this. Well, basically, we're doing the same thing. Okay, so now, first thing I want to know is, let's do our null hypothesis. Again, we discussed our assumptions. Now let's do our hypotheses. This time we're really doing it in the right order. H null and H alt. Okay, so H null is that's an easy one. The proportion during the regular season is equal to the proportion during the playoff season, right? So now what's our null hypothesis? Proportion during the regular season, right, is what? Let's see. Does the home team win more games, right? Does the home team win more games? Well, now we're saying that the home team wins more of the games. There's a higher percentage than during the regular season. So we're saying that the proportion during the regular season, the proportion, is smaller than the proportion during the playoffs. Okay, I'm going to make this a little bit. Okay, well, that means that really what we're looking at as the null hypothesis is that the proportion during the regular season could be either equal to or greater than the proportion during the playoffs. Okay, so now this, because there's more, it's not just different. There's percentage home team wins the home team has different during the playoffs than the regular season. We're actually looking for, is it greater than is the playoffs that the home team wins during the playoffs, percentage that they win during the playoffs, greater than what they win during the regular season, which means our alternative hypothesis satisfied only if the playoff games during the playoffs is a higher percentage than the regular season. But our null hypothesis is satisfied both if they're equal to and if during the regular season the home team wins more games, right? So why smaller and not equal to? Jennifer, I'm not. I'm sorry, Joshua. You say when you say smaller and not equal to. Well, because that's really saying playoffs. You can look at it both ways. Percentage playoff wins for the home team is greater than for the regular season, which is less than. So you can look at it. This is less than. This is greater than. Okay, good. Thank you. I went back to an old question, so I didn't see you. Okay, so let's take a look at this. How are we going to now? Again, let's say that again our level of confidence that we want is 95%. In other words, an alpha of 0.05%. Okay, again, our distribution now is going to look like Get another one of these. Okay. Okay, see what our distribution is going to look like here. During the regular season, oops, got this upside down. During the regular season, the home teams won 58% of the games, right? And now during the off season, we want to know how far above this does our percentage have to be for the playoffs, so a sample of the playoffs. How far above this does this have to be so that this only has a 5% chance of occurring? Where we're no longer interested in the bottom half. We're assuming that it can't be lower. You know, the playoff wins can't be lower. A home game wins can't be lower than the bottom. Whether we're justified in saying that or not, that's what the problem is telling us. So all 5% of this can be in here, right? So if we go to our Z table and we want to look up on our Z table what that Z score has to be, right? What does that Z-score have to be? Well, that Z-score is the same Z-score that we would normally use for 5 and 5 or a 90% confidence interval, right? Or if I just looked up what the Z-score would be for a value where this is 95% or less. Normally for 2.5, we would look up 97.5, right, on our Z-score and go down. So I'm not going to go to the Z table. I'm just going to tell you that that Z-score has to be 1.64. Everybody agree with that, that that Z-score is now 1.64? Can it be written, let's see, playoffs greater than, yeah, you could write it that way, absolutely positively. Jennifer pointed out, you could also write it the other way. Playoffs equal regular, less than a regular season, null hypothesis, alternative hypothesis, playoffs, a proportion of playoffs is greater than the regular season. You could write it either way. In other words, you could flip this around as long as the open side of that little caret is next to the playoffs, because you want to make sure you're saying that this is bigger. You could say percentage of playoffs is greater than the percentage during the regular season, be equivalent. You would also then rearrange this as well. Playoffs, percentage during playoffs is equal to or less than the percentage during the regular season. Okay, so yeah, you could do it either way. It doesn't matter. Okay, so everybody comfortable with this 1.64 and why I'm using that 1.64 now instead of using 1.96. You know, you can't just say, just answer another question. You can't just say that that H null is equal, because there's two conditions that satisfy it, not just equal, but it also could be significantly less than the number of wins during the regular season. So you want to phrase your null and alternative hypothesis so they cover all possibilities. Okay, so if I just said equal here, well, I'm not covering the possibility of the percentage during the playoffs being greater than the percentage during playoffs, right? So I really want to cover all possibilities. So if I ever say greater than in one of these things or less than in one of these things, the other one is going to say equal to or the opposite, right? So it's always going to say that. Okay, so let's go back to this. Okay, so now let's do this calculation. What formula are we going to use for this? Okay, well, we're going to look for what that t-score is or what that z-score. Now, we know that one of the assumptions that we made here, in addition to independent samples and normally distributed these proportions, the other assumption that we made is about the sample size if we're going to do this. And the sample size says that the sample size has got to be greater than 30, right? Which it is, it's 64, but there's another qualifier. Both sides, both the that we draw from,